Here's an example of how we use the Pythagorean theorem to determine if the lengths of three sides of a right triangle can be as those given in this example. So you see that it asks, can the following distances be the lengths of the sides of a right triangle? Well, what we need to do is picture first a right triangle. The longest side of that right triangle, of course, always has to be across from that right angle. So in this case, that would be 5. That's called the hypotenuse. And the legs would need to be the other two lengths, 3 and 4. Now, if they are truly possible lengths of sides of a right triangle, then I should be able to use the Pythagorean theorem to verify that they are, in fact, going to satisfy that equation. C always has to be the hypotenuse of that right triangle. So A and B would be the lengths of what are called the legs. One leg is 3, so we'll take that leg and square it. The other leg is 4, so we'll take that leg and square it. And if they are truly the sides of a length of a right triangle, or lengths of the sides of a right triangle, then when I take 3 squared plus 4 squared, they will equal the hypotenuse squared. Well, let's check that out. 3 squared is 9, 4 squared is 16. Does 9 plus 16 equal 5 squared? It certainly does. So we would say that yes, these are possible lengths of the sides of a right triangle. We also want to be able to use to be able to determine the length of a missing side of that triangle. In a previous video that I made, we found the missing hypotenuse. But here's an example of a problem where we have a right triangle, and I give you the length of a leg of that right triangle, 8, and the hypotenuse of that right triangle, 10. And I ask you to find the other leg. We can call it A or we can call it B. It doesn't matter. Well, if those are sides of a right triangle, then we can use the Pythagorean theorem to determine the length of A. So each leg squared, which in this case would be 8 squared plus A squared, must equal the sum of those legs squared, must equal the length of the hypotenuse squared. Now I know, according to Please Excuse My Dear Aunt Sally, I need to do the exponents next. So 8 squared is 64, and 10 squared is 100. Now the inverse of adding 64 to A squared would be subtracting 64 from both sides. And I end up with, at this point, A squared is equal to 36. And finally, the opposite of squaring a variable is to square root that variable. So I need to square root both sides, and I know that the square root of 36 is 6. So in this right triangle, the length of the other leg must be equal to 6.